Hello and welcome back for the second part of lesson 6.2. And we're going to just continue on with a few examples to help you build your understanding of the normal probability distribution, the curve, and how to find probability and X values, depending on what you've been given. So you try it, number 3, have your Desmos open. In the United States, the ages 13 to 55 plus of smartphone users approximately follow a normal distribution with approximate mean and standard deviation of 36.9 years. So the average smartphone user is 36.9 years old with a standard deviation of 13.9. So X can be distributed as N normal with a mean of 36.9 and a standard deviation of 13.9. This is what we're going to be using our main thing in Desmos. And question A says, we're looking at determining the probability that a randomly selected smartphone user is between 23 and 64.7 years old. So we're going to draw that on our picture first. So the mean is 36.9, which is between those two ages. So that means I'm just going to draw a dot for my mean, 36.9. And then I'm going to draw a line on the left for 23. And then a line on the right for 64.7. Let me show you on my paper how I'm drawing this. So we are looking between here. Mine doesn't have the question on here, but your paper should. So the probability of X being between 23 years old and 64.7 years old is what we are looking for. So we're going to go to Desmos. The Desmos link for this lesson should be in the modules. You can always find that there. And I created folders. So there's a folder for that one. We're under the folder for you try it number 3. And we are looking for between 20, let's see, I got the wrong thing. 23 and 64.7 years old. And then I'm going to hit my magnifying glass so that I can make sure that I'm looking at the right graph. So that is what we should have shaded. And it looks like that probability is 0.8186. So 81.86% of users are between the ages of 23 and 64.7. Okay, let's look at the next one. The next one says, find the 30th percentile and interpret it in a complete sentence. Okay, so the 30th percentile, a percentile means that we know that we want to find an X that is less than something, because percentile is a less than, and it's 30% of the data needs to be less than this value. So half is here. So that means 30% is over here somewhere. And we always draw our percentages and probabilities on the top. Remember that. And we want to find this X down here. So that's what we're looking for. So we have to use the inverse CDF of the normal distribution of 36.9, comma 13.9, comma 0.30, because that is the left area and that's what Desmos likes. So let's go to that. So we're going to type inverse CDF of, and then I'm going to just put my CDF. And then I've got to go and delete this up thing here. And then I'm deleting that. Okay. And it looks like 30% of the smartphone users are less than 66.43 years old. 66.43. Oopsie. No, oops. I put in the wrong link. That didn't copy over for some reason. 36.9 and okay. That looks more appropriate. 29.61 years old. Even I make mistakes. I'm human. 29.61. It didn't look right. So I'm going to turn off the last graph. And it won't do this graph because I'm giving it the area. But we could check our work here, right? We could check that and just make sure that makes sense. Because I could say, if I think that 30% of my data is less than 29.6 years old, I can do a cumulative and put in up to 29.61 and make sure it comes out to about 30%, and it does. So that's how we can check our work. Okay. Let's go back and try this. Look at this one here. It says, what is the probability? So we're looking for probability that the age of a randomly selected smartphone user is less than 27 years old. So we want to know the probability of X being less than 27. And so again, that's our mean is 36.9. So that means 27-year-olds are going to be to the left. And we want to know this area right here. That's the question. So we're going to just use our regular normal distribution. So let's go to that. And decimals to check it out here. And I'm going to copy that and put that there. And it's cumulative up to 27. So it looks like 0.2382. So about 23.82% of the users are less than 27 years old. So I bet maybe 5-10 years ago, that age, the majority of our users was actually less than a really young age, because maybe not as many older people were using smartphones, but I'd say that more of the older generation are using smartphones, so that's going to increase. Okay, so let's go ahead and flip the page and look at the next example. We've got two U-Try-Its for you to try here. And so let's read through this one, and I'll give you a minute, pause the recording, and you can work on this on your own, and then we'll come back and do it together. 2,000 students took an exam. The scores on the exam have an approximate normal distribution with mean of 81 and standard deviation of 15. Calculate the first and third quartiles. Okay, and what does this tell you? And 60% of the students earned at least what score in the exam? Okay, so these are some interesting ones. Remember, first and third quartiles is Q1, and Q3. And Q1 is 25%, and Q3 is 75%. So I'm going to let you pause the recording and try this one on your own with what you know so far. Okay, let's see what progress you've made. So we're looking for the Q1 and the Q3, because the Q1 is the first quartile, it's 25%, and Q3 is the 75th percentile, which is the third quartile. And let's mark those. So 25% is going to be over here. So this is going to be 25% to the left is going to be Q1. And then essentially, I'm going to do the other one here in shading with my highlighter. So this one is going to be Q3, which is going to be 75%. And that's going to be all of this. And because we're using percents and we're trying to find X values, we're going to use the inverse. So we want to find the X that is less than, right? Something that equals 25% is our Q1. And then probably the X is less than something that is 75% is our Q3. Okay, so let's go back and find those in Desmos. And so you can see I've got a folder for that here. You try it number 4. So the 25%, we're using the inverse CDF because we know the area to the left is 25%. So that marking is 70.88 on the exam. So 25% of the students scored less than 70.88, and it looks like 75% of the students scored less than 91.11. Okay, wow. So let's go back to our paper for a minute. So we have those values. And the cool thing is because we know the Q3 and the Q1, we can find the IQR, which is Q3 minus Q1, right? So 91.11 minus 70.88, which is 20.23 in the middle. So 50% of our data scored between these two values on the exam. Okay. Let's look at this one here. It says 60% of the students earned at least what score on the exam? So at least, using our table of inequalities, means bigger than. So we want to know, let's do some purple here, easier for you to read. Probably the X is greater than something because that's at least. And we want that to be 60% of the students. Okay, so now we know the area to the right. So area to the right is 0.6, and that's because it's a greater than. And so we want 60% over here. So that means we want 1 minus 0.6, which is 0.4 on the left. So that has to be less than the 50% mark. So we have 0.4 over here, but we want to know this 0.6 over here. We want to know this X value, right? But we have to use this in Desmos. In the inverse CDF, okay? And so let's go and put that in. Let's write it out right now so that you know how it should be typed. Now remember, you're going to copy my Desmos so that you can have it for yourself. So it's going to be inverse CDF, parentheses, normal dist, D-I-S-T, parentheses, the mean of 81, comma, 15, okay, parentheses, close it out, and then do a comma for the area to the left, which is 0.40, and then a big parentheses. Okay, so these two should have parentheses together, and then these two should have parentheses together. So let's go back to our Desmos where we were working. And I'm going to copy that. and enter and paste. And we are looking for 0.4. So it looks like 77.2. 77.2. So 60% of the people scored at least 77.2. 40% of the people scored less than 77.2. Okay, let's flip and look at the very last of the problems here on our page. It says a citrus farmer who grows mandarin oranges finds that the diameters of mandarin oranges harvested on his farm follow a normal distribution with a mean diameter of 5.85 and a standard deviation of 0.24. Okay. So they follow this. X is normally distributed with 5.85 and 0.24. So read through this and see what we can come up with, and then catch me back and we will go over it together. Okay, let's see how far you got. A says, find the probability that a randomly selected mandarin orange from this farm has a diameter larger than 6.0 centimeters. Sketch the graph. So larger than means it's going to be a greater than. Probably the X is greater than 6.0. And we want to know what that is. So let's just draw our mean is 5.85. So 6 is going to be to the right somewhere. 6. And we want to know this probability here. Okay, so let's go and find that in most. So I have my normal distribution. I'm doing 6 to infinity right here, and it's on my graph. And I have to turn off my graph from this. Oh, I've got some other graphs turned on here. There it is. This is what we're looking for. So the answer is 0.26598. So 0.266, we'll say 0.266. So 26.6% of the mandarin oranges have a diameter bigger than 6 centimeters. It's important to be able to write that out in words so that you know what you're getting. So 26.6% of all the mandarin oranges are wider in diameter than 6 centimeters. Okay. The next one says the middle 40% of mandarin oranges from this farm are between what and what? So middle 40%. So not 40% over here, 40% over here. I need middle 40%. So let's just draw that and kind of figure out how we're gonna, what our strategy is gonna be. We want the middle 40%. Now we did the middle 50% back on Untitled number 4, right? Our IQR is the middle 50%. That is the definition of the IQR, Q3 minus Q1, which is the between the 75th and 25th percentile is the middle 50%. So we need the middle 40%. So middle 40 means if we take 1 minus 0.4, we have 60% on the outsides. And half of that 60 is going to be to the left and half is to the right. So let's take 0.6 and divide by 2, which is 0.3. So that means we have 0.3 over here and 0.3 over here. And so that adds to make 1. So this marker here, right, we need to have marker 1. So let's just do our lower and our upper. So L is going to be with a 30%. So L is going to be the probability that X is less than something, which is my L, is equal to 0.30%. So let's find that first using the inverse because we know the percentage. Let's do that. Okay, that's right here. Inverse CDF. So let's just make a mark of that for you all. The diameter 30%. Okay. This is the bottom 30% because you put in 0.3. So 30% of the mandarin oranges have a diameter less than 5.72. 5.72. So okay. So we need to find the next one. So between 5.72, let's mark that right here. So this one's 5.72, and then we need to find the other for the middle 40%, sorry. So that means this boundary is going to be 0.3 plus 0.4. So this upper one is going to be where 70% is lower. Probably where X is less than something equals 0.70%. So that's what this one's going to be. So let's go look at that one. Desmos. So we just have to mark it at the 70. Okay, so that would be 5.98 in centimeters, 5.98 centimeters. So anywhere between that. Okay, so let's go to our last question here. So for the middle 40% is between 5.72 and 5.98 centimeters wide. So 5.98 centimeters. Okay. The last question of the lesson. Find the 16th percentile and interpret it in a complete sentence. We've been doing a lot of interpreting, so we should be getting good. 16th percentile means the probability of an X being less than something where 16% of the data is less than that. So that means anything less than 50% is on the left. So that's 0.16 over here. We're going to find this X that marks the 16%. And Desmos only takes the left-hand area, so that's perfect because that's what we know. So we're going to use the inverse CDF with okay, so our whole scenario, but we're going to use 0.16. So let's go and find that. 0.16, and there it is. Just make a note here for you. So it looks like 16% of the mandarin oranges are less than 5.61 centimeters wide. Okay, so let's go ahead and go back to our paper and write that out because we want to write out what this means. 16% of the farmers mandarin oranges are less than 5.61 centimeters in diameter. This is good information for him, right? So he knows kind of what to expect, or when something unusual might happen. This would not be unusual because it's not less than 5%, but he could start to think about, what if he gets an orange? I mean, an orange that is, what would that be? So let's just look that up. What would that be to be less than 5%? It would actually be anything less than 2% out here, 2.5%, right? Or 2.5% bigger. So let's just go back and look at that. Desmos in here. Let's just copy that. And let's just do this one separate. So anything that is 2.5%. So anything that's less than 5.38 centimeters wide, right? And we could just do 1 minus that to do the right-hand side. And anything bigger than 6.32 would be unusual. So, wow. Okay. So that concludes lesson 6.2, part 2. And you've learned a lot, hopefully, about the normal probability distribution. And catch me back with any questions.